Here's the tendon of stapedius. Its muscle belly is enclosed in bone back here. The stapedius muscle tilts the stapes backwards. The head of the stapes articulates with the incus, which will add to the picture. Here's the incus. The incus moves the stapes and is in turn moved by the malleus. The incus has a body, a short crus, and a long crus. The long crus curves medially, ending at the lenticular process, which articulates with the stapes. The short crus points backwards. The tip of the short crus is tethered to the wall of the tympanic cavity here by the posterior ligament of the incus. On the front of the body of the incus there's a saddle-shaped joint surface at which the incus articulates with the malleus. Here's the joint surface. We'll add the malleus to the picture, together with the ligaments that hold it in place and the bone those ligaments are attached to. We've already seen that this part of the malleus that hangs downwards, the handle or manubrium, is attached to the tympanic membrane. In the dry bone, this is the manubrium. This is the head of the malleus. This joint surface, facing backwards, articulates with the incus. The malleus is suspended by two ligaments which are attached here behind and here in front. This is the anterior ligament. This is the posterior one. The two ligaments are in line with each other. The malleus makes a rotating movement through just a few degrees around an axis of rotation that's in line with the anterior and posterior ligaments. There's very little movement at the joint between the malleus and the incus. The two bones move together. The movement of the lenticular process causes a tilting movement of the stapes. Movement of the stapes is restrained by the action of the stapedius muscle. Movement of the malleus is restrained in a similar way by a second small muscle, the tensor tympani. Here's the tendon of the tensor tympani. The tensor tympani muscle is enclosed in a bony tunnel here above and parallel to the auditory tube. Its tendon turns a corner as it emerges from the bony tunnel. The tensor tympani pulls the manubrium and the tympanic membrane medially. The stapedius and tensor tympani muscles act in response to loud noise. Their action helps to protect the inner ear from noise damage. Lastly, we'll add to our picture of the tympanic cavity one highly unusual nerve, the chorda tympani. The chorda tympani, a branch of the facial nerve, emerges from bone back here, passes between the malleus and the incus, and leaves the tympanic cavity up here on its way to join the lingual nerve. As we saw in a previous section, the chorda tympani conveys the sense of taste to much of the tongue. Now, let's review what we've seen of the structures of the external and middle ear. Here's the auricle, the external auditory meatus, the helix, the antihelix, the tragus, the antitragus, and the concha. Here's the cartilage of the auricle and the cartilage of the auditory meatus. Here's the tympanic membrane, the pars flaccida, the pars tensa, the umbo, and the annulus. Here's the tympanic cavity, the vestibular window, the cochlear window, and the opening for the auditory tube. Here's the malleus, the incus, and the stapes. Here's the tendon of stapedius and of tensor tympani, And here's the auditory tube. I hope that in future editions of this atlas we'll find ways to show the inner ear as well. For now, we're at the end of this section on the ear. We're also at the end of this tape, the second of two that describe the head and neck. In the next and final tape in this series, we'll look at the internal organs.